This is Mr. Martin. These are the video notes for Geometry Honors, section 10.9. We got the last section for the chapter. So we're looking at circumference and arc length, and I think most of this we've already looked at before, so it should just be a review for you. So again, circumference is really just the perimeter of a circle, and we have the formula. It's either pi times diameter or 2 pi r if you want to use the radius. Either one is fine. And then when we're talking about the length of an arc, I've mentioned this in the past, it's very important that you realize that it's different than the measure of an arc. The measure of an arc is the same as the measure of the central angle that it corresponds to. The length of the arc is if you were going to walk from one point on the circle to another point on the circle, how far did you walk? Okay, so let's take a look at a couple examples here. If you want to pause the video and see if you can work these out on your own, feel free. So we have a 30-degree arc and we want to find the length of it if the radius of the circle is 20 centimeters. So it's going to be 30 divided by 360 times the circumference, so that's times 2 times pi times the radius, which is 20. And when you plug the numbers into your calculator, if you just plug in 30 divided by 360 times 2 times 20, and then you do convert it to a fraction, doing your math frac, math enter, it's going to give you 10 thirds, and then we just throw the pi in there, so it's 10 thirds pi, and then we have units in the problem, so we want to include them in the answer. So 10 thirds pi centimeters. Moving on to part B, we've got a 125-degree arc, so this would just be 125 divided by 360. That's the fraction of the circle that we have, times 2 times pi times 20. And again, just plugging in those numbers without pi and hit your math enter, you're going to get 125 ninths pi centimeters. Alright, so that's the length of those arcs. So let's take a look at something that extends upon this a bit. We have the diameter of a bicycle wheel is 80 centimeters. So here's our bicycle wheel. And we know that the diameter here is 80 centimeters. Okay, how far will the bicycle travel if the wheel rotates 2,000 times? So if the wheel rotates one time, so one revolution, that's going to be the circumference. So that's going to be 2 times pi times 40, because we're going to use the radius, so that would be 80 pi centimeters. So every time it goes around, it's going to go 80 pi centimeters. So that would mean that 2,000 revolutions, that would be 2,000 times 80 pi centimeters, which gives us 160,000 pi centimeters. Alright, so how far is 160,000 pi centimeters? Well, that's going to be approximately 502,654.82 centimeters. And if I want to convert that to kilometers, I would move it 2 places for meters, and then another 3 places. I think I missed in there somewhere. 1. So it's going to actually end up over here. Alright, so we just move the decimal to go from centimeters to kilometers. We have to move it 5 places, so we end up with about 5.03 kilometers. So, and then we could figure out how many miles that would be if we wanted to, but we can see it's going to be a little less than 5 miles. Alright, so that's how far you would go if the wheel rotated 2,000 times. Moving on to part B, how many revolutions will the wheel make if the bicycle travels 20 meters? So now we're kind of working backwards. So we know that 20 meters is going to be 2,000 centimeters, because a meter has 100 centimeters. And we know, since our wheel has a circumference of 80 centimeters, that one revolution is equal to 80 pi centimeters. We figured that out in the first part. So if we take our distance and we divide it by the distance per revolution, we've got 2,000 centimeters divided by 80 pi centimeters per revolution, and this will tell us how many revolutions. It's going to be approximately 7.96 revolutions. Okay, so just under 8 revolutions. That's pretty much it for this section. Again, most of these concepts should be review. Any questions, make sure you ask me, and we'll see you next time.